Hey guys, so today's notes are 84A, and the goal is going to be to learn how to solve application problems involving quadratic functions. So, sorry for the wrong date on the paper, we'll scratch that out. The first thing today is to review how to work with projectile motion. And so, in this situation, we have some real life things happening. First, in this function, this negative 16 is going to represent gravity. Because we know that in any situation we have something in the air, gravity is a constant force pulling everything back down to the center of the earth. Our b term, which we know from before, is now going to be our initial velocity. So the b term that we now look at, that number, is initial velocity. If I'm throwing something up in the air, if it goes up, it's positive. If I'm slamming it down, it would be negative. And then lastly, we have what we know as our c term, which is now h of sub 0. And that's going to be the initial height of the object. From where is it being released from or thrown from? So here are three kind of values. Here's A, B, and C. A is gravity. That's a constant negative 16 when it's in feet. The B number is now your initial velocity, how hard it's being thrown or if it's being dropped. And then the C value is now your initial height. From what height is it being released from? Now, over here on the right, we have a different number for gravity because sometimes we might have a question that's going to be written in meters. So whenever gravity, the question is in terms of meters, we will use a different value for gravity if it's negative 4.9. So again, just to be clear, this is going to be gravity whenever we're talking about feet, or we have a unit of using feet. When it's in meters, we use a different number for gravity. Otherwise, we used to have initial velocity and initial height. So with that, then, let's go over today's examples. And it's short today. So the first thing is, we want to talk about some projectile motion. So example A. A cannonball is launched into the air. The function h of t equals negative 16t squared plus 96t plus 3 models the height in feet of the cannonball in the air after 2 seconds. So we can still identify here A, B, and C the exact same way. And then it asks me, how long does it take the cannonball to reach its max height? Whenever you get a question involving max height, what that's code for is find the vertex. Whenever you want to find the max height of an object, it means find the vertex. And to do that, we have a formula, which is negative b over 2a. So in this question, I can just apply this little formula, negative b over 2a, using this a, b, and c here on the side, and I can find the max height and how long it took to get there. So to start, negative b over 2a, I'll kind of draw out my skeleton. Now notice how b here is 96. So negative 96. Do that again here, it's a little bit messy on my part. Negative 96. And then to a is negative 16. So I'll drop a negative 16 in that parentheses, which leaves me with negative 96 on top and negative 32 in the denominator. And then if I divide this equals to 3. So basically what I just found is that it took 3 seconds for my cannonball to reach its max height. So that's how long I can find that. If I want to find out what the actual height is, the actual max height, I need to finish finding the vertex. So here on the side, here's how this works. When you find the vertex, the x-coordinate is how long, the time it takes, and then this would be max height. So if I want to find the actual height it reaches, I need to find the y, or for us it's the k value. So to do that, I'm going to take my original question, so negative 16 t squared plus 96t plus 3. So again, I'm taking the original problem up here, and I'm going to input what I just found for time, which is 3, into my original function. And with a calculator, I'll work this all out. So I'll input a 3. Whatever comes out will be my max height. So let's go ahead and start. 3 squared is 9. So this is 9 times negative 16 is negative 144. Then 96 times 3 is going to be positive 288, and then plus 3 more. Then negative 144 plus 288 is going to be 144 plus 3. So the max height of my cannonball will be 147 feet. So that's it. So today's notes is when you're looking at some kind of projectile motion, if I want to find the max height and how long it took, it just means find the vertex. And to do that, it's negative b over 2a. Go ahead and pause the video and please try example B. It's the exact same setup but a different scenario, and then come back and check the answer. Alright guys, so here's example B. So a javelin is thrown into the air. Here's your function. So how long does it take for the javelin to hit max height? Here's negative b over 2a. Plugged in my b and my a values from the original function up above. It takes 2 seconds. To find the actual height it reaches, I plug the 2 back into my original function, so back into where the t was at, and I work it out to find that it reaches a height of 70 feet. Alright guys, examples C and D, this is going to be a different kind of setup, but they're going to be area problems involving quadratics. So C says, the length of a rectangle is 1 centimeter less than twice the width. So down here, this is 1 centimeter less than twice the width. So there's that description. And then it says the area is 45 squared centimeters. So the actual area we know we're given is 45 squared centimeters. So in this example, notice how we were given from this formula, from the area which is length times width, we're given all the parts here. So area here is 45. So I can replace the area with 45. And then length and width, I'll call this is the length. And then here's our width, which is already here as W. So the length here is going to be 2W minus 1 times, and the width is just W like it is here on the picture, so times W. So in this example, I can find the area given those two dimensions. If I want to work it out, I can do that now. So first, W, I can distribute the W into this binomial. So W times 2W will be 2W squared. Then W times negative 1 is negative 1W. And that equals to the area which we're given of 45. At this point, this is a quadratic equation, but notice how it's not in standard form because it's not solved for 0. So I can take this 45 and I can move it to this other side to make this equal to 0. So to do that, I can undo a 45 with a minus 45. So I'll do it to both sides. And this cancels. So what I'm left with is 0 equals 2W squared minus 1W minus 45. Now at this point, this is my quadratic equation in standard form. Notice how my A value is 2, my B value is negative 1, and my C value is negative 45. So now what I could do is I can solve this by factoring. So I need some space here, so I'm going to get rid of all this work here. And I'm going to just work from here. So here's A, here's B, and here's C. So let's go ahead and do the X. So if I X factor this, A times C is going to be 2 times negative 45 is negative 90. So negative 90 up here. Then my B number is going to be negative 1. Now if you look at this carefully, guys, as you guys get faster at this, you can do this with less work. Do you see how 90 is 9 times 10? So if I can recognize that right off the bat, I can just do that directly. So 9 and 10, or I'll make the 10 negative, and that'll work. So I take the original quadratic, so 2W squared minus 1W minus 45. I'm going to now split my original B term as 9W minus 10W. That's still just minus 1W. And I have 2W squared, then minus 45. Now I'm going to group. First two, last two. These share a W in common. So I'll take that out. And then these two happen to share a negative 5. So if I divide that out, negative 10 divided by negative 5 is positive 2. And then negative 45 divided by negative 5 is positive 9. So notice how I expect this because, as we've said many times now, when you factor, you expect these to be the same. And it still is, so I'm still good about that. To finish, I'm going to get 2w plus 9 as one factor. And then w minus 5 as my other factor. Now that equals to 0. So here's my factored form of this exact same quadratic. So here's standard form, here's factored form. To finish this question, I'm going to solve by taking each factor. So taking each factor and setting it equal to 0. So I'm going to dip below here real quick. So 2w plus 9 equals 0. And then w minus 5 equals 0. So if I solve these kind of quickly, again, this is not new to you. We've done this for several weeks now. I can find that the width here will be negative 9/2. That's one solution. I can solve the second factor by adding 5 and find that the width here is 5. Now, here's our last little bit. So I found my solutions. Negative 9/2 and 5. But the thing is, if we get the actual question in rectangle, can length be negative here? And it can't. So even though I got two answers in my work, this negative answer here doesn't really make sense. It's called extraneous, so I can ignore it. So my answer here is width is 5. So if the width is 5, this will be 5. Then here, what's 5 times 2? 5 times 2 is 10. 10 minus 1 is 9, so this is 9. And does that make sense? Is 5 times 9 45? It is, so we found the area of our rectangle and we found our dimensions. Okay, and with that, pause the video, please try example D. When you come back, hit play, you have the answer. And that's today's lesson, guys. Alright guys, example D. So I'm going to start here kind of halfway. So notice how I first set up my quadratic. So the area is 96 squared centimeters. And then I have length, 4 plus w times width, which is w. When I multiply this out, I get this quadratic. I move 96 to the right. Notice how here, if I just follow my work, it's kind of jumbled. So remember that when you guys have standard form, it should always be your squared term first. So w squared is first. Your in this case, w term is second. Your b term is second. And your constant is your c term. So this is your quadratic for this question. Your goal is to factor that. So at this point, using your a is 1, b is 4, and c is your negative 96, go ahead and factor and solve that. Come back and get the answer. Alright guys, so here's the rest of the work. So now we have our standard form ABC here. I did the x factor here on the left and found that negative 8 and 12 would make this work. So here on the right, I can split my original b term of 4w into negative 8w plus 12w. I can factor by grouping all the way down to here. So here are my two factors. And I can solve each factor setting it equal to 0. And notice how, again, like last time, because this is a rectangle with side lengths, I can't use any negative answers. So this negative 12 that I've computed, even though I can get the answer there, it doesn't really make sense to the question, so I can ignore it. It's called extraneous. So my answer will be that width is 8. If the width is 8, this would be 8. And then 4 plus 8 is 12. And notice how 8 times 12 is 96, so I can verify my work. Alright guys, with that, that's today's lesson. Remember, we're going to be checking in Tuesdays and Thursdays on a Google form, so do that tomorrow, please. And guys, for tomorrow, that's all it's going to be, is just a check-in. Wednesday, you're going to have a test review, which you're going to work on for Wednesday and Thursday. And then I'll open up a test this Thursday again for a few days to work on factoring and solving and graphing. Alright guys, have a good day.